Good afternoon, everyone. Welcome to our second session for the game theory. Last time we started game theory. Uh, if I'll just revise quickly what we did in our game theory portion, we started with the objective of what the game theory is, what are the different ways to solve these problems, right? If we discuss as in terms of main topics, then it is going to be just a minute. Yeah. So we discussed about the basic terminologies, definitions related to the game theory, in which we have seen what a player means, what does the different strategies, how they are said to be pure strategy or the mixed strategy, right? Strategy was nothing but the planning, plotting what we thought, or we take the action whenever and against of us the person who is playing is taking some opinion. With his opinion he is taking some action, and corresponding to that we are taking an action keeping that in mind that you want to win the game, right? Both the players are interested in winning the game. So while doing these strategies we observe, sometimes it is direct, we are aware of it, we know like it is going to be equally likely chances for the happening of that, and sometimes it may be it's a mixed of the two. So whenever it is mix of two, how to resolve it? Because again, it is leading us toward the chance, right? So indirectly we observe, I'm taking decisions. Those decisions are uncertain because of the risk. So they are dependent on the probability, right? So whenever such all these things are prepared on a table, we receive a payoff in which we are observing with respect to different course of actions, with respect to the different strategy of my different players, how much is going to be the gain of one, how much is going to be the loss of one, right? On the basis of this, we can simplify it. We have created some algebraic methods. By using them, we can find out how to solve. So in our last lecture, we started with the basics as of what the pure and the mixed strategy based games, how we create the payoff, and how we can solve them, and in which we have gone through some examples, right, where we are able to get the saddle value or the saddle point. What was the saddle point? The saddle point is nothing but that equilibrium point of your game. Or you can say, if I want to find the saddle point of a given metric. Now question comes, why this metric is coming here? Obviously I'm able to give the quantified values, right, to different with respect to the different strategies of the different player. So two steps we have followed. We have done it as minimum value of each row and then maximum value of the each column. Now question comes, why do you want to have in a minimum value of your player A? So I'm assuming that the gain of a player A is nothing but the loss of player B, right? So to represent this part, I'm saying that these are going to be the minimum losses what A is going to bear, where player B is going to have his maximum losses, right? Then only I'm going to say that the player is going to be is going to be the winner. So the this methodology we have adopted, and we come across with some certain value, and that certain value is nothing but telling me the value of the game, right? So what if we just go quickly for an example, this is the player A, its payoffs are given here. I'm going to find out the minimum of the player A. How I'm going to find the minimum of player A? Player A is adopting the first strategy. In against of that, player B is adopting one, two, three, four. Anyone can he can adopt, right? So what I'm going to do, I'm going to take the minimum of it. I'm not going to take this as an absolute figure. If some figures are representing negative, I'm going to take it as it is. Here, the question may come in a mind, why and how this value could be negative. This negative 2 is indicating that this is not the profit of A, this is profit of B, or you can say the negative 2 is nothing but the loss of person A. If suppose player A is going to have strategy 1, and if player B in against of that adopt his strategy 1, player A is going to lose 2 2 units, or you can say if it is in terms of a monetary gain, 2 rupees. This is what we understood. And what this 0 is indicating, no profit, no loss. Okay. And similarly, we will calculate the maximum of the column wise. So once I receive the row minimas and column maximas, right, then what I have to do? I want to maximize the chances of the player A. So I'll take the maximin, that is maximum of all row minimas. So this is all about kind of a uh, strategies and chances of winning, right? So this is everywhere chance part is involved. Minus 2, 1, minus 4, and minus 6. So I can see the maximum number is 1 because other three are nothing but indicating my losses. So definitely I will go for that profit wherever it could be a smaller value, but still it is profit, not the loss. And in the same way, we are going to have the minimum of all my maximum column values. So we can we can see here, these are 5, 3, 1, and 5. So minimum is coming 1. So we observe here the maximum and minimax is coming equivalent. You can see here this is coming 1 and this one is also coming 1. So that means the saddle point arised. And what is the value of the game where these two are intersecting? That is again 1. So this is, as the system is very pure in the nature, I am able to solve it easily, right? And this how we have done multiple questions based on it, if you remember. We have seen sometimes a 2 cross 2 matrix is given. That means player A is adopting two strategies and player B is also adopting the two strategies. So we can solve them by augment out methodology. And these were the few formulas we have derived. Let's say I don't remember the formula, so we can do it by the expected value. Chances of winning plus chances of loss is always equals to 1. So if I'm saying player A is having only two strategies, A1 and A2. So their corresponding probabilities are going to be what? P1 and P2. So sum of P1 and P2 is going to be how much? It is going to be 1 because it is nothing but the sum of the probabilities corresponding to the player A. In the same manner, I can do it for the player B, and then we have derived these formulas. Do we have to remember these formulas? No. By looking at the data values, we can manipulate and we can receive it directly. But yes, if you are able to remember, you can associate it with the given position values. So things will be easier. We have solved few questions on it, right? And here we end up with what is how to solve. Done. Now today we are going to move ahead with some more complicated scenarios. So far, we were just saying that multiple strategies are adopted and usually they are in form of a square matrix. That means if player A is adopting four strategies in against of that, the player B is adopting the same, right? Or it could be like only 2 cross 2 matrix is absorbed. What will happen if I'm having a multiple sets and maybe they are not equivalent, right? They are not square. They are coming in terms of 2 cross m or m cross 2. That means I'm having two players with multiple strategies. In this particular scenario, the principle known as dominance rule or principle of dominance play a very important role, right? So when we are talking as in terms of principle of dominance, so here again we are going to concentrate with respect to the player wise, player A and player B, right? So what I said that in some games it is possible we need to reduce the size of payoff matrix. If my system becomes 2 cross 2, I just observe that how I can simply solve it, right? So by keeping this as my motive, if a multiple ordered data set is given to me, that means 2 cross m or m cross 2 game is considered, then I will try my best to make it 2 cross 2, right? So to make this 2 cross 2, how what I'm going to do, I'm going to eliminate the rows or I'm going to eliminate some columns. Or you can simply say we are going to adopt the dominance of the player A wise and the player B wise, right? So let's say there are two major principles we follow. Number one, the dominance property for the row and the dominance property of your uh, column, right? Now, what is the meaning of this dominance property of the row? In simple words, if I am having multiple rows and I will observe the entities of all rows, right? If all the entries in a row should be lesser than or equal to the corresponding entries of another row. If this particular thing happen, right, then what I'm going to do, I'm going to delete the row with minimum values. Let me write it and explain you. Let's say I'm having the figures as A1 and A2. I'm having these two strategies which are going to be followed by the player A. In against of the player B, let's say the player B is adopting B1, B2, B3 and B4 strategies, right? And let's say the figures are given 1, 3, 5 and 9. These are the random values I have written just to make surety that you understood the dominance rule for the row. And let's say the figures are written here like this. So if you observe all the values of my A1, that is 1, 3, 5 and 9 for BIs, B1 to B4 and compared with the A2s, that is 2, 6, 9 and 10. So this 2 is greater than 1, 6 is greater than 3, 9 is greater than 5 and last 10 is also greater than 9. So what we observed, all strategic values of my A1 is coming lesser than that of my A2. So in this scenario, we are going to do what? We are going to eliminate the row with the minimums, right? The row minima is going to be cancelled out. So I am going to simply eliminate this. If we connect it with the geometrical representation, we understood that the person A, I'm working along the process of person A is going to win. So wherever his chances of winning is less, I'm going to eliminate it. I'm going to dominate it. And how I'm going to dominate it? By using the those values which are showing me the chances of winning is here more, right? So this is how I adopted for the row. If we are moving ahead, sometimes it may possible that you can dominate it through the columns. So keep the thing in a mind. We are working against the A, right? So wherever in the B, if let's say I'm having one more A3, as in but condition applied, keep this thing in the mind, all the values, it should not happen that one or two value left out. It should not happen. Now here the value is 3, 7, 8 and 12, right? You could have said that madam 2, 6, 9, 10 is greater, 3 is greater than 2, 7 is greater than 6, but unfortunately this is 8, so this is not feasible. So once I'm done with my all rows, I will go for the column wise. That means in favor in terms of player B. So where whatsoever is coming higher, I'm going to eliminate it. Why I'm going to eliminate the higher values? Because it is in favor of player B and I'm working in favor of what? Player A. So 6 and 7, 6 is greater than 2, 7 is greater than 3, so I can eliminate it. 9 is greater than 2, 8 is greater than 3, so I can eliminate this, right? So this way we can eliminate rows and the columns by keeping that row minimas and column maximas. Sometimes you will observe that this simple rule is not working. So in that scenario, what you have to do, you need to take the average of the two. We can take the average of the two strategies and then corresponding with some other value we can compare. If that is justified, that is also feasible. So with when the examples will come, I'll explain you that point as well. So let us begin with the first question where it is written that you need to go by the dominance method, right? So I'm having player A with some strategies, player B with some strategies, and their payoff matrix is also given. So what we are going to do, we are going to follow the dominance rule. So first I'm going to do with respect to the player A. That means I'm going to compare it row wise. So if I see 3, 5, 4, 2, 5, 6, 2, 4, these two are not comparable. Why not comparable? Because I can see that this is crisscrossed. Compare A1 with A3. So 3, 2, 5, 1, 4, 4, 2, 0. So yes, it is coming equivalent. So equivalent condition also we can adopt to make it more concrete and easy to understand. 5 compared with this 3, 6 compared with this 3, 2 compared with 5, not feasible. 4 compared with 2, not feasible. So when I compared my second and the fourth row, I am not able to justify this and my values are not in the dominance format. Let's go for the third row and the fourth row. 3 and 2, 3 and 1, 5 and 4, 2 and 0. So yes, it is giving me all the values of my A4, fourth strategic values are coming strictly greater than that of whom? A3, right? So I am working corresponding to the player A. So minimum of the row, whatever is the minima, that is going to be eliminate. That is going to be that is not going to be the part of my system. It is going to eliminate. So I eliminated the fourth row. So it has gone now. So which initially system was 4 cross 4. Now again one can ask here, ma'am, you were saying it should be 2 cross m cross 2. I said if a system is a large enough, right? Maybe it's in a rectangular form or maybe in a form of a square, right? Doesn't matter. The important point what you have to take is whatever is minimum, it is going to be that is going to be eliminated. So this A3 has gone. So what was given to me as of a 4 cross 4 matrix, now it becomes 3 cross 4. Until what I'm trying to reach, I want to reach up to 2 cross 2. So keep this objective in a mind that moment it becomes 2 cross 2, I know multiple methods to solve. Okay. Now here again if you compare you will see uh, row wise not it's not feasible. Now that's why I have to go for the column wise. So when I compare the second column with my fourth column, 5 is greater than 2, 6 is greater than 4, 3 is greater than 2. What I need to eliminate? Wherever it is larger. So 5, 6, 3 is larger, so I'll eliminate the B2. Move ahead. Compare 1 and the third. 3 greater than 2, 5 greater than 4, 3 greater than 2. There is no thumb rule that you have to go once only for the column, then for the row. No, you can use multiple times the row, multiple times the column, and you can come up with your solution. So I cancelled out and I reached to this matrix, and which is of 3 cross 2, 3 rows and 2 columns, 3 strategies followed by player A and 2 strategies followed by player B. Again you check 5, 4, 2 and 2, right? So it is indicating that there is a chance that I can go, I can compare, right? So you can see row 1 is less than or equals to row 3, less than or equivalent to row 3. So remove your minimum value that is of 3. So keep every time this is minimum of the rows and maximums of the column need to be cancelled out. Then once you reached here 2452, can you see what I received? I got my 2 cross 2 matrix. Now it is quite easy for me to calculate all the answers, right? Now question comes, what answers? What are the chances of the chances for these strategies? What is the value of the game? All these type of a thing, right? Last time we did it. Again, I'll solve this portion also just to make sure that we are okay with it. 5 and 2. So simply I'll subtract the values. I want to see this figure. So to get us 5 minus 2, you got 4. 4 minus 2, you got 2 here. 4 minus 2 is 2. 5 minus 2 is 3. Some of them is coming 5. So their probabilities are this much. Right? 3 plus 2 is 5. Every time I have divided it. To get the value of the game, it is going to be 2 times 3 by 5 plus 5 times 2 by 3 divided by the total. So this is how we can simplify. Let's see one more question to concrete the concept of dominance. 172, 627, 516. 6 is greater but 2 is not. So I cannot compare A1, A2. 5 is greater, 1 is not. So you can't compare row wise. Now let's see column wise. 7 greater than 2 not, 1 not. 2 is greater than 1, 7 is greater than 6, and 6 is greater than 5. So yes, if I could have started with B1 and B3, I'm observing all the values of B1 is coming lesser than that of B3. So what you need to eliminate? B3 because you compared columns. So it is gone. 6 is greater than 1, 2 is greater than 1. Not feasible. 6 is greater than 5, 2 is greater than 1. So yes, now once I have reduced it in 3 rows and 2 columns, I can compare A2 and A3. And what I'm observing? I'm observing that the value of all the values, important thing, huh? All the values of my A2 is coming greater than that of A3. So what you need to eliminate whenever you do the row wise, minimum you eliminate. Minimum. So what is minimum? Minimum is 5, 1. So this is gone. So you got 1762. So yes, this is nothing but what is expected from us, right? Then the same procedure in this particular one, I understood the player A is going to have A1, A2 with some probabilities, A3 with 0, B1, B2, B3 with 0. Why? Because now at the end, A1, A2, B1, B2 left in the game, right? So this is how we can do by using the dominance. Okay. But it has been observed after applying the dominance, after applying the settle point condition, everything, sometimes it is tedious to solve it. It means what I was saying, my matrix is of a 2 cross M and 2 cross N. After applying the dominance, still my values are coming in set of rectangular, right? They are not coming square. They are not ready to convert into the 2 cross 2. So to solve such type of a problems, we have the next methodology, that is the graphical method, where we are after the dominance, make sure after the dominance you are receiving your payoffs in form of 2 rows and n columns or m rows and 2 columns. So how to adopt this 2 cross n matrix? Let's begin with the first one. When it is 2 cross n matrix, what is the meaning of 2 cross? I'm having the only two strategies followed by player A1 and A2. 2 rows are there. But in against of that, the player B is adopting multiple strategies. It could be B1, B2, B3, and up to Bn, right? So whenever this particular thing happened, when you are writing, there are strictly 2 rows. What you need to do, we are going to create the graph for all possibilities. So let's see what are the steps. Number 1, draw 2 vertical axes 1 unit apart. So it is not simply going to be as in a first quadrant of x and y plane. No. What they are saying, you need to draw the 2 parallel tracks in this manner, right? 1 unit apart. It's your choice, but some distance you need to keep them. And you can call them, this is my x1 at 0 because it's the origin line, and this is my x1 with the 1, right? Take the point of first row in the payoff matrix on the vertical line, x1 is equals to 1, and the point of second row in the payoff matrix of x1 equals to 0. In short, if I say whatever the points are given to me, I'm going to convert it in a form of in form of the expected values, and then I'm going to plot it. Once I will plot all my equations or all my given data set values, then if the system is made up of 2 cross n, that means there are 2 rows and n columns. Or other way of understanding, 2 strategies by player A in against of n strategies of player B. right? So this analytical method will give us some area, common region. As if you remember in our linear programming problem, when we started for the graphical method, we were looking forward for a region which is bounded by all given limitations, right? And by looking at that feasible region, I'm very much sure that the point which is far away from the origin is going to give me the maximum profit. So here also we are going, whenever we are working along the A corresponding to A, what is the thumb rule? The thumb rule is first you calculate the minimum of all the rows. This is at least this fellow is going to earn, right? Among these, at least pick the maximum. So my player A is always following what? Maximum criteria. So here also, when we are working with the 2 cross M matrix, I'm working corresponding to whom? I'm working corresponding to the player A. And what I have to do? First, I need to calculate the minimum area. So once you have received this type of a, plotting, right, you can see here this is x1 equals to 0 and this is x1 is equals to 1. You have plotted the figures, right? These are my points. I'm observing here after the plot. I'm going to take the below area, right? It is not going to be bounded. It is going to be upward or the downward. So take the lower area. We call the name as lower envelope. And for this lower envelope, pick the point which is highest in it. Then it is nothing but what? Maxi min. So here if you observe, this is the point which is maximin. So wherever you receive this maximin, check this point you received by using what two strategies. That means what are those two line segments which are generating this particular point. So you can see here this is made up of 2 and 12, right? This is your B3 and second one is yours um, 3 and 6, that is your B2. In short, what I observe, which was given to me as an in a 2 cross form, again I reached with 3, 6 and 12, 2, right? Simply simplify that. So I said that to get the, if I'll write here A1, A2, B1, B2, right? So for the A1, if you want to find out, simply do it with respect to A2. So 6 minus 2 will give me the value 4. So write the 4 here. To get this value, 12 minus 3, you will get the 9. For getting this, 12 minus 2, that is 10. 6 minus 3, that is 3. Sum of them, it is going to be same, that is 13. So if I'll write the probabilities, 4 by 13, 9 by 13, 10 by 13, and 3 by 13, right? So these are nothing but my chances of adopting that particular strategy. So player A is going to have strategies with 4 by 13 and 9 by 13. There was no other one, right? So these two only, such strategy. And strategy of B, if you will write, so it was with B1, B2 and B3. Who is involved in the system? B2 and B3. This is my B2 and this is my B3. So that means B1 should be 0. B2 is going to be 10 by 13 and last is going to be 3 by 13, right? Now, value of the game. Now, value of the game, simple. Your 3 times 4. 3 times 4, that is 12, minus 6 times 9, 54, divided by the sum of the two. That is 4 plus 9, 13. This is plus 66 by 13. So whatever is your answer. So this is the logic of 2 cross n. Let's see one more question. Solve by graphical method. So already dominant metric is given to us, but it may possible sometimes you have to make the mix of the two. You are adopting the dominance, You are adopting this max mean mean max criterion, then you are applying the graphical. So see the question and then you take the call. Now if I go by this example, I can see this is again 2 cross 3. That means I need to work corresponding to the player A. If it is a player A, then it is always maximization of all your minimums. That means I need to find the lower area, and for my lower area, whatsoever is the highest, I'm going to take it, right? So if we plot it, how I'm going to do it? The first figure is 4 against A1, against A1. So A1 is coming here with 4, right? You can see this is my A1. So this is my 4 and minus 1. So where is the minus 1? The minus 1 is here. So this is your A2. Then second, minus 1 and 4. So this is your minus 1 and this is your 4. 0 and 2. So 0 over here and 2 over here. So once you have created all, yeah, one more most important thing, just neglect this line. It's of just for our understanding that they are one unit apart, right? Origin to origin is matched. So that is nowhere involved in it. So what is my lower area? The lower region, I received this one. Question, why lower region? Because I'm working for the player A. So I'm looking forward for the minimum of the area. And for this minimum area, whatsoever is the highest. So this is this point. So this point is my maximean problem, which is made up of what two equations, what two strategies. The strategies are with 4 and minus 1. That means the B2 is involved. This is, you can give the name also. This is B2, right? And second is 0 comma 2. So that is your B3. So these two are involved. So I'm going to take this as, you can see here, 4 minus 1 and 0, 2. This is the equation. Okay, okay. This is not the term. This is B1 is involved. B1 is involved. So 4 minus 1, 0 and 2. Same thing. To get this figure, I need to add these two. 2 plus 1. And ignore the minus sign. So that is coming 3. 4 plus 0, 4. 2 plus 0, 2. 4 plus 1, 5. Divided by the sum of these two. 3 by 7, 4 by 7, 2 by 7, 5 by 7. So these are what? These are the chances of adopting that strategy. Value of the game, different ways. Either you go by this formula, then also you will get the same answer, or simply 4 times 3, 12 minus 4 divided by the sum of the two. So 4 minus 12 minus 4 is 8 by 7, right? So this is how we can calculate the value of the game. Suppose I want to go by this formula. So by this formula also we can calculate. What it says? It says A11 into A22. So cross multiply 8 minus the product of the two, 0, divided by A11 plus A22. Cross multiply addition 6 minus of A12 plus of A21. So that is minus 1. So you got 8 over 6 plus 1, 7. So see, either you go by the formula or you go by the shortcut. The answer is always going to be same. Okay. Just to summarize, whenever you are adopting the graphical method after the dominance, when your system is made up of 2 cross m, what you need to do? A unit apart, you just need to plot them. After plotting, check the minimum area. And among that minimum area, across that minimum area, check the value where you are getting the maximum point. So this is how we do for the 2 cross m. Now let's see the second portion. That is my m cross 2. M cross 2 means player A is going to adopt multiple strategies, but player B is going to adopt only two strategies in in against of it, right? So this is my m cross 2. Same methodology, two parallel tracks, vertical lines axis we are going to draw as one unit apart. right? So the two lines are x1 is 0 and x1 is 1. Take the points of the first row on the payoff matrix on the vertical line x equals to 1 and the point of second row in the payoff matrix of the second one. So same way how we have done, we are going to plot it. Once we are done with the plotting, now as this is multiple rows are there, right? So what you have to do, you need to get the maximum area, and for that maximum area take the minimum, the deep valley, right? So if you can see here, I'm not going to check the lower values. Why? Because this is the maximum criteria. What we did before was your minimax area, minimax criteria. So you got upper area, and for that upper area you got this as the minimum point, and which is made up of the strategies 3 minus 3, some value, and this is minus 1. So if I'll compare it, I understood that I left with A2, right? That is 3 and minus 1, and second is minus 3 and 2, right? So the reduced one, what I got here as in a form of a 2 cross 2 is B1, B2, A2, A3 with figures as 3, minus 3, minus 1 and 2. Done. Now we will calculate the value of the game on the probabilities. So this becomes 5, this becomes 4. Simply I am adding for the A2 when you want to write the A3s you add. To write the value of A3, A2s you add. For this B1s if you want to write, simply add these two. So 2 plus 1 is coming 3 and this is also 6. So 5 plus 4 is 9. So what is the chance? 5 by 9, 4 by 9, 3 by 9 and 6 by 9. Right? So these are nothing but your strategy values. And now the question comes value of the game. So 3 times 5 plus minus 3 times 4 divided by the sum of the two, that is going to be 9. So I'm getting the figure 3 by 9, which is equals to 1 by 3. Done. So this is how we can find out the many mix maximin. I'm applying the same criteria, that is minimization of all maximum column values or maximization of all minimum row values. Why? Because I understood that I'm writing in terms of the player A. So player A has to have minimums of the regret, and player B is going to have maximum of losses. Let us have one more question graphically. I'll just take a pause of 2 minutes. Is anybody is here in the session? Let me just check. Okay. Sakshi, as you are here, can you just confirm? Are you able to understand any question, any doubt? Sakshi, are you there?
Yes,
Are
ma'am.
you
Then,
are you following? Are you able to follow this?
actually, ma'am, I don't take the 2 or 3 classes previously, so I don't understand.
Okay. So is there anything like if you understood or anything like if I'll make clarity for that particular point for my today's session, it will be helpful for you?
Yes, ma'am.
Yeah. So did you understood the maximum and min max principle?
No, ma'am.
Okay. So let me just revise quickly for you. What is this game theory? In the game theory, we have players, right? So this is my player A, and I'm taking the another player, player B. You can just assume that you and your friend is playing any of the game. So usually what happens? Let's say you started with this first action A1, right? With because of your first action, the player will take the another action, right? Now he took the second action, so now it's your chance. You are going to have the second action, and corresponding to that, it is going to be his chance. And in this manner, we can keep going on, right? But at the end, we decide whether player A is winning or player B is winning, right? So to judge that, this entire game theory has been designed, right? And on what basis I am deciding? On the basis of Let's say player A is taking A1 strategy, B is going by the B strategy. Somebody is going to win something. So player A is going to have 2. So I'm writing in favor of A right now. If suppose I'm writing minus 2 here, what does it mean? When player A took his A1 strategy, player B in against of that played his second strategy. And because of that, player A1 is going to lose rupees 2 or the amount 2 or the quantity 2. Right? So this is nothing but if the figures are written in this manner, these values are nothing but creating a payoff matrix. Did you understood this much? Did you understood this much?
Yes, ma'am, little bit.
Yeah, little bit. Then once you have created the matrix, now the question comes, find the solution, right? And whenever we are finding the solution in a game, obviously there are multiple doing it, right? So very first thing what we call is nothing but we check, is there any saddle point? What is the meaning of this saddle point? That no profit no loss condition, we are reaching to a point where you are going to have some value of the game, and where there is a mean max mean criteria is justified. Now question comes, what is this mean max mean? Two criterias, right? So to get this particular one, l- what we have to do, we need to calculate the minimum of the row minimum. So this is my first row. Figures are 2 and minus 2. I'll write the minimum of this. 3 and minus 4, minimum is 4. Right? Among these two values, take the maximum. Right? So what is the maximum? Minus 2. So we call this minus 2 is nothing but what we call this maximum of all minimums. That means player A was losing minus 2. Player A is losing minus 4. Among that, how much is going to be the maximum? In the same manner, if I write for the player B in favor of the player B, I'm going to have maximum of it. So that is going to be 3 and minus 2. And then you take the minimum of that maximum. So that is coming how much? Minus 2. Right? So this is minus 2. This is minus 2. So what I can conclude? I can conclude mean max, or you can write minimax, is equals to maximin. And how much is that? It is coming minus 2. So directly you got the value of the game. This is nothing but the value of the game. And to get this value of the game minus 2, what strategies are adopted? The person B is following the strategy B2 and player A is adopting A2. So this is my first criteria what we did in the last class. That is your max mean x. But now today we learn that if suppose this is not simple 2 cross 2, it is a complicated methodology. So what you need to do, let us have one more question. A1, A2 and A3. B1, B2 and B3. Right. And some payoff matrix are given. 2, 3, 4, 5, 9, 8, 1, 3, 1. Let's say I randomly have taken this as a metric. So we learned today, we started today with the dominance. So whenever we talk about the dominance, we can do it by the row wise and we can do it with the column wise, right? So if suppose R1 is coming less than or equivalent to R2, right? Whatever is the smaller, so R1 is the smaller. So I need to delete this. And if I'm comparing C1 with respect to C2, whatever is a larger, C1 is going to be deleted. Why, ma'am, the row is the minimum and the column is maximum? Because I'm working corresponding to the player A, right? So how we can do it? Look at this one. If I start with the comparing A1 and A2. So 5, 2, 9, 3, 8, 4. So what you are observing that all values of my A1 is coming lesser than whom A2. So whatsoever is the letter is smaller is going to eliminate because of the row minima. So what I am going to eliminate? I am going to eliminate 2, 3 and 4. Done. If I again compare, 5 is greater than 1, 9 is greater than 3, 8 is greater than 1. So if I compare A2 with my A3, I am observing that all the values of my A2 is coming greater than A3. So which one I'll eliminate? Whatsoever is the smaller. So smaller is with 131. Done. Now I left only with the one row, that is with 5, 9 and 8. Again, now I cannot go by the row. I have to go by the column. So if I'll compare, B1, right, is coming lesser than B2. So whatsoever is the larger is going to be eliminated. So therefore this has gone. B1 with B3, this one is left. So what is the final answer? This is my final answer. That is nothing but 5. And this entire process we are able to simplify with the max mean and min max criteria. What are going to be the strategies? The strategies, if I check here, I'm going to have the values as A1, A2 and A3, right? Where the values are going to be 0, 1, 0. 100% I'm going to do it. So this is pure strategy. 1, 0, 0. This is my 100%. But whenever there is a mixed strategy, and I'm not going to have the value of the probabilities to occur as a 1, it is going to be in a fraction. Fine. So this is what I explained. Did you understood something better than before, Sakshi?
Yes, ma'am.
Okay, great, great. So let's have a revision. Let's have a one question in which we can summarize everything, whatever we have learned. Fine. So I'm taking one question on the board only, where you will find everything whatsoever we have done so far. It is going to be combined. Okay. Do you have paper pen with you? Can you follow my instructions and solve this?
I have.
Yeah, okay. So let's say I'm asking you there is a player A and he is having strategies A1, A2, A3 and A4. And there is another player B which is having some strategies to be followed, and those are 5 in the number, B3, B4 and B5. And because of this, I'm getting some payoffs. So like 4, 6, 5, 10, 6, 7, 8, and 6, 8, 9, 4, 5, 11, 10. So this is going to be there in the problem with us. Either it is given directly or maybe in a word format it is written, you can prepare. Done. So I'll just take the uh, okay. Done. So what we have to do, the question is, following is a table representing the payoff matrix with respect to player A. We have to solve the entire thing with respect to player A. Solve it optimally using the dominance property. Solve by using dominance property, right? So what I said, you start with any of the row or any of the column. Before we go for the dominance, let us do it with max mean mean max principle, right? So what does it says? It says, before I go for this, simply I'm going to do it with the mean max and max mean principle. So what you have to do, you need to create a new column we called row minimum. First row, the minimum value is coming 4. Second row, minimum value is 5. Third row, minimum value is 8. Please correct me if I'm wrong anywhere. Fourth row with the minimum value 4. So you got 5, 4, 5, 8, 4. Done. Then you call here column maximum. Column maximas are 8, 9, 11, 10, and 10. Right? Then among these row minimas, find the maximum. We call that maximin. Maximum of your row minima. So I have row minimums are 4, 5, 8, and 4. So what is my maximum? Maximum is this 8. Am I right? Similarly, here I'm going to have minimax. What is the meaning of minimax? Minimum of column maximas. So what is this minimum of column maximums? Minimum, now 8, 9, 11, 10, and 10. So what is the minimum of this? This 8. So did you observe? Here also you are getting 8. And here also you are getting 8. And wherever they are intersecting, that is also 8. So what does it means? It means max mean, maximean is equals to minimax, and which is equals to 8. Therefore, the value of game is coming how much? 8. Done. And what are the strategies? Strategies are A is going to have the value as with A3, and B is going to have the value as B1. So A is going to follow his third strategy, and B is going to follow his first strategy. So if I want to write the values in terms of strategies, right? So how I'm going to write the strategies? The strategies are going to be player A with a scope of 0, 0, 1, 0, 100% pure. Why? Because I got a clear-cut indication that A3 should be adopted, not the A1, not A2, not A4. So that is zeros. And similarly, for the player B, if you write, the first one is adopted, so 1, and remaining are 0. Right? So these are nothing but indicating your conclusions in terms of simple way. But they asked us, this is the max mean max principle, but what they said that do it by using the dominance principle, right? So if I want to go by the dominance principle, I need to adopt the dominance rule, right? So let us adopt the dominance rule. So by dominance, right? So you can begin with any of the thing. Just observe, just see the data set. As I can see here, in if I'm comparing A3 and A4, A3 and A4. So 8 is greater than 6, 9 is greater than 4, 11 is greater than 10, 10 is greater than 6, 9 is greater than 4. So all the values of my A3 is coming greater than A4. So which one I am going to eliminate? I am going to delete A4. Implies delete A4. Why delete to A4? Because this is minimum, right? So simply cancel your A4. Again, you compare. Now, if I'll compare with respect to A1, any of that, 7, 4, 8, 6, 5, 5, 9, 10, 10, 9, not feasible. 8, 4, 9, 6, 11, 5, 10, 10, 9, 6. Yes. So I got this. This is my first step, row wise. Second, if I'm comparing all A1 with all A3, so what you are observing, your A3 is coming greater or equivalent. A3 is coming greater or equivalence to A1, right? Can you see 8 is greater than 4, 9 is greater than 6, 11 is greater than 5, 10 is 10, 9 is greater than 6. So what does it implies? Again, whatsoever is the smaller, right? Delete whom? Delete A1, which is minimum. Why to delete? Because I have to work along player A. So I eliminated it. If I compare A2 and A3, I cannot satisfy this dominance rule of row. Reason behind this is not justified. So now that means I need to go for the column wise. Third, I'll go for the column. So let's say I'm comparing my B1 and B2. So if B1 and B2s are combined, 8 is greater than 7, 9 is greater than 8. So B2 is coming greater than this. So what it means? Delete the bigger one because it's a for the player 2. Player B, delete B2. So this is gone. Step 3. Step 4. Again pick anyone. 9 is greater than 7, 10 is greater than 8. So I'm getting B1 is lesser than your B3. Sorry, B4. Right? So which one I'm going to delete? I'm going to delete which is larger, B4. So B4 gone. 10, 5 greater, but 9 is not possible. 10 is greater than 7, 9 is greater than 8. Yes. So fifth step, if I compare B1 with B5. So B5 is coming larger. So what it means? Delete B5. So if I'm deleting B5, this is gone. So what left? What left? My reduced matrix is going to be with A2 and A3. And here I left with B1 and B3 with figures 7, 5, 8 and 11. Right? If you compare, 8 is greater than 7, 11 is greater than 7. So it means you are again adopting the row dominance. So A3 is coming greater than A1. So which one you are going to eliminate? Delete, delete A1 because rows are minimum. So simply, sorry, A2 actually, A2. So delete this. Again, 11 is greater than 8, so I can eliminate it. What left? You got 8. And what is this? This is nothing but my value of game. What strategies? A3 and B1. That means 1, 0, 0, 0, 0 and 0 because 5 were there. And this one 0, 0, 1, 0. So what you were getting before, the same you have got received here. Only the difference is I adopted here the dominance rule and there I applied the mean max, max mean principle. Is that clear to you, dear? Okay, great. I think you left the session. Fine. So this is how we have to follow. We get the solutions for our game theory problems. So as I did here today for the graphical method, for the mixed strategies, for the pure strategies, right? And then we can simplify it. So as I have planned more questions, but as there is a limitation of time, so whatever is in a PPT that is sufficient, you can follow your SLM and in case you find any difficulty, please connect with us so that we can rectify it. Okay. Thank you, everyone. Have a good time.